In this demonstration, we're going to show you how to import in some 3D vectors that were created in another CAD package, adjust the XY datum, and then use those vectors to create very simple tooling to cut a two-sided part. In the end, we'll take a look at our 3D preview of those toolpaths and note any problems that may occur and show you how to fix those. We're going to start this demonstration off by opening up an existing file. And we're going to navigate over to our V10 tutorials in the Conrod folder in the Conrod files, and you'll find a conrod.dxf file. Now this file contains vectors that we created in another software package and are going to import into your software so that we can demonstrate how to use a two-sided job to visualize this finished part and then also save off the tooling for it. So we're going to open this up. And right away, we're going to see those 2D vectors I just mentioned. So let's go and set up our job. This is going to be a double-sided job. Now, before we set up our job size, it's important that we choose the units that we're going to use first. So in this case, we're going to use millimeters. And the actual job size is going to be 130 millimeters by 60 millimeters. And the thickness of our pre-made piece of aluminum is going to be 12 millimeters. And we have the choice to zero off our material or our machine bed, or we can zero off the same side if we would like. But in this particular case, because it's an already pre-made piece of aluminum that we assume is perfectly cut, then we can just go ahead and zero off our material surface. You'll see that there's the XY datum position. Now it's set to the bottom left, but we also have some offsets here that were set in the file that we imported in. These may be there because maybe the aluminum block that we received has a special spot where we need to start from. And so that's indicated by this -16 and -26. So it's -16 across the X and then -26 along the Y. So that lines up perfectly with where the center of this small circle should be. Now we're going to flip bottom to top, and we don't need to worry about our design scaling, and we're just going to click OK. Now, to get things going, we're going to need to prepare our vectors for this file. They did come in the way they were expected, but because this is a two-sided job and we want to center our vectors inside of our material, then we're going to need to make a few little adjustments. So to do that, we're going to select all of the vectors that we have. Now we could press F9 on our keyboard, or we can go ahead and use our Align Selected Objects. So we'll click that, and we're going to use this option right here, which is Align to Material Center. If we click that, then it's set right to its center. So we can close that down now. Now you'll see that straight away our datum XY is now not in the proper spot. So we need to get that back to the center of this small circle. And there's several different ways you can do that, but one method would be to actually figure out what this offset is and then just translate that into our XY datum positions and just offset those the same distance. So first of all, let's go ahead and choose to draw a polyline. And if we snap to our bottom corner, we can then drag this up and hover over top of this corner of our rectangle. Now, we don't want to click there, we just want to hover over it. And we want to look at the numbers that we have up in here, our cursor positions. And the two that are most important are the DX and the DY, diagonal X, diagonal Y. So if we hover over that, and you can tell that we've snapped to that corner because our crosshair is a square, a hollow square with the crosshair marks. And if you look at the DX and the DY, you'll see that the DX is 6.5 and the DY is 4. So we need to jot those down someplace or remember them. And then we can click Close and go back to our job dimensions. Click that, and then we can just use those two numbers and adjust our offset. Now, because it's a negative number, we're going to have to make sure that we end up putting another negative in there. So -6.5. And if we press equals, then you'll see that we have -22, and that datum has now been reset. And then we can just go -4 equals. Now our Y datum is now fixed. And we can click OK. So that was pretty easy. Now we set this up to be a double-sided job, and there's some important things we need to know about how a double-sided job works. First of all, we have two extra icons up here. One tells us the flip direction that we've chosen, so that's handy to know. And then we have this icon here that tells us what side of our material block we're on. So the brown rectangle is our material block, and the arrow tells us what side we're on. So right now we're on the top. If we click it, we're now going to be on the bottom. If we click it again, we're going to be on the top. Now we can also use the number keys on our keyboard, 1 and 2, to flip from the front and the back. So number 2 is the back, number 1 is the front. Number 2 is the back, number 1 is the front. Let's go back to the second side for a second. Now we can tell that we're on the second side, not only by that icon there, but also the rulers here are orange. And also any vectors that were on the front side are now light blue, and we can't actually select them, but we can see them, so that way we can make sure that things are lining up properly, or if we need to line up something with something that's on the front, we can do that easily by looking at those light blue lines. Now let's go back to our front for a second. Now, because we're going to actually use the same vectors on our front as on our back, we're just going to need to quickly copy these vectors to our back side as well as the front. So we're going to select those. If we right click on those vectors, it says copy to the other side. And now if we go to our back side, you'll see that the rules are orange. So that means we're on the back side and we have the same set of vectors. And just to be sure, let's just temporarily move this one out of the way. And we can see that there's the light blue one from the front side, and it's exactly underneath the black line from our new backside vectors that we just copied. So let's just Control Z that and put that back where it belongs, and go back to the front side again. You may ask yourself, why did we select our vectors and then right click on them and choose the copy to other side option? Well, when we did that, the software takes into account our flip direction and will flip those vectors appropriate to the direction that we've chosen when we set up our job. Instead of just using copy and paste, and then us trying to have to sort that out, our software does that for us, which is pretty neat. Okay, now that we have all of our vectors set up, let's start to develop some of our tooling. So let's flip over to our Toolpaths tab. And just to make things a little bit easier, we should go ahead and tile our view top to bottom. That way we can see our 2D view in the top and our 3D view in the bottom. As always, we're going to have to check our material setup, and this is the actual physical setup that we have on our CNC machine. We need to make sure that our software knows exactly where everything is. So we're going to go ahead and click Set, and we'll start off with our material thickness, and yes, it's 12 millimeters. We are going to start at the bottom left corner, and that's the datum offsets that we fixed earlier, which are perfect. We're going to zero out the top of our material, and we need to make sure that our rapid Z gaps and home start position are safe and appropriate for our machine and our setup. That way we'll clear any of our hold down fixtures and so on. So all of that looks pretty good. We might just change this to be 10 millimeters, and we'll change these clearances to be 5, just nice round numbers. And then we'll click OK. Now our first set of toolpaths we're going to make are going to be for a pocket to clear out some material around the 2 holes in our connection rod. So we're going to go ahead and choose, holding down our Shift key, we're going to select this outside rectangle, and we're going to select these 2 large outside circles, and we're going to create a pocket toolpath. Now our start depth is going to be 0, and we're going to go down 2 millimeters, and that's actually going to pocket out a nice big chunk of material. I'm going to get rid of all that extra material, mainly so we don't have to waste time cutting down through it when we do our other pockets, and also it will take away that material so that we don't have the extra pressure on our tool when we're cutting. So we're going to go -2, we're going to go down 2 millimeters. We can show our advanced options, but we're not going to use all of those, but we can show them. We're going to select the tool from our tool database, and that's going to be in our metric tools section, in our end mills section, and we're going to choose 6 millimeters. Now these settings are fine for right now, but we're going to go ahead and change them temporarily for our particular tool path. We don't want these to be permanent adjustments to our 6mm end mill. So we're going to select what we have right here. And then we're going to go into our edit feature of our tool. And now we can make some quick changes here that will make it so that when we cut our material, it'll be safe and we won't hopefully break a bit. So we're going to be change our pass step, and we're going to leave our pass step to be 3mm. That's fine. Our step over, we're going to change to 20%. We're going to slow down our spindle to 3000 millimeters per second is the units we're going to use. Our feed rate is going to be set to 5mm, and our plunge rate is going to be set to 1 mil. Remember, we're cutting into aluminum, so we're going to want to slow down our machine quite a bit, and we'll click OK. We're not going to use a large area clearance tool. We're going to choose to use the offset pocket, which will give us the result that we want. We don't need any allowance at all. We're going to use some ramp plunge moves, and this is going to be 16mm. And we're going to use these across our project. That way it'll just take off some of the load that we're going to put onto our tool so that we can end up, hopefully prevent a breaking of our tool. And we're going to click calculate. And you'll see in our 3D view the result of that, and we can preview that visible toolpath. And that's exactly what we want, except for it's in Canadian maple. So let's change this over to look a little bit more realistic. We're going to flip that over to our metal, and we're going to use steel bright, and we're also going to use our material color to color our machined areas, and that's what we hope to have. That looks perfect. Now we're going to want to cut the same toolpath for this one on the other side of our part, and the only way we can do that is to actually go to our second side. So we'll click to go to the bottom. We'll close down our preview toolpaths window, and we're going to now go ahead and create another pocket toolpath. Now the software will remember some of the things that we set up for the other toolpath. So it's going to remember that we want to do a cut depth of 2mm, which is great. We're going to need to select our tool. We're going to select that 6mm tool again, and we're going to temporarily edit those things again that we need to do. So we'll change this to 20%. We'll change this to 3000. We'll change this to be 5 and this to 1. Now if we're going to use this tool a lot, it might be to our advantage that we actually create a new tool with these settings in it. We'll click OK. We're not going to use the large area clearance tool. We're going to use an offset strategy. We're going to use the same ramp plunge moves, and we're going to calculate that. And it's going to tell us we don't have any suitable vectors. That's because we need to actually select some vectors here in our 2D view. We can calculate that. Then we'll preview that visible toolpath. That looks perfect. And in our 3D view, we can actually look at both sides of our project at the same time. So that's perfect. So let's flip back to our top again, and let's look straight back down on our material again on the top side. Close down our preview, and let's go ahead and set up our second toolpath, which is going to be to cut out this section here in the middle, which we're going to use to lighten up the weight of our connection rod. We're going to use again a pocket toolpath, so we're going to select that vector. We're going to pocket that out. We want this pocket to be 2mm deep, but we've already removed 2mm, so there's no need for it to start back at 0 again. We may as well start 2mm down. We're going to cut an additional 2mm, so the bottom of this will be 4mm in. We're going to select our tool again. It'll be 6mm. Going to select that. We're going to edit it. We're going to go ahead and change our settings again. 5 and 1, and we'll click OK. We're going to use offset strategy. Again, we're going to use our ramp plunge moves at 16mm, and we're going to go ahead and calculate that, and we'll preview that. Looks good. Now we're going to do the same on the other side, so let's flip back over again. I'm going to select this vector from the back side. Close down our preview toolpaths. We're going to pocket that out. We're going to start at 2, go down 2. We're going to select our tool again, 6mm. Select that, edit it again. make this 20%, make this 3000, make this 5 and this 1. Click OK. Same settings as the other side, so it's going to be a offset strategy. We're going to use our ramp plunge moves at 16, and we're going to calculate that. We'll preview that visible toolpath, and then we'll have a look to make sure that both sides are looking the way they should. And that looks really good. Let's close that down. Now the next two toolpaths we're going to make are only going to be cut on one of the two sides. And this is where you can choose depending on your setup. I would like to cut them from the back side, mainly because one of them was going to be a profile cut to cut out our material. And if we do that from the front side before we cut the second side, it might be a little bit unstable and might break loose. So I feel that cutting it from the back side is probably a better option for us in the end. So we're on the back side already, so that's great. Let's just look straight down on our part. Perfect. And the first toolpath we're going to make is going to be a pocket toolpath again. And we're going to pocket out these two circles right through our material. So we're going to start at 0, and we're going to go all the way through the 12 millimeters of material. We're going to select our tool, same tool as before. We're going to edit that tool. We're going to change this to be 20 again, 3000, 5, and 1. Okay. We're not going to use a large area clearance tool. We're going to use the offset strategy again. We're going to use those ramp plunge moves, and we're going to calculate that. And when we preview this, it's going to cut right through our material. So that's great. That looks really good. Perfect. Now our last toolpath is going to be a profile cut. That's going to cut around the outside of our connection rod, and we're going to leave some tabs on it so that it will stay connected to our original material block, because we don't have any kind of a vacuum hold down or anything like that. So let's go ahead and click a profile toolpath. Now this one we're going to start at 0. We're going to go down the full depth, the 12 millimeters. We're going to select that same 6 millimeter tool again. We're going to edit that again to be 20%, 3000, 5, 1, and OK. We're going to go on the outside of that line because we actually want to cut on the outside of this line right here. Okay. No offset. We're not going to do a separate last pass. We are going to add in some tabs, and we're going to make these tabs 4 millimeters in length and 4 millimeters thick. Now, if you remember, we pocketed the other side out 2 millimeters. So in the end, these tabs are only going to be 2 millimeters thick, not 4. So you're going to want to keep that in mind. We are going to edit those tabs, and we're going to go ahead and place some in here. So we're just going to add in our own random tabs. And as soon as we see a check just below the add tab icon there by my cursor, I can click and the software will add a tab in for me. So we'll put one there, one here, and one there. Close that down. And then we're going to add in some ramp plunge moves, the zigzag ones, which are the same as that we had on the front. We're going to change these to be 16 millimeters. And we're going to rename this one cutout. And we're going to calculate that. And then we'll preview our visible toolpath. And you'll see straight away that from the back side, we've got some tabs. When we take it off the machine from the front side, that's what the tabs are going to look like on the front. And that looks pretty nice, I think. So let's look straight down on that again. Now, because our toolpath previews are so accurate, you can really use these to see any potential problems that may come up during the cutting of your part. Now, in this case, you can see where our profile cut is now hitting into the full depth of our material because we haven't pocketed out far enough. Now, this probably isn't going to be a huge problem, but if when we were planning out our part, we decided that the depth of the material or the thickness of the material after we pocketed out both sides was the maximum that the tool could handle. Then when it does run into this full depth of material, then there's a really good chance that the tool might actually break. So let's take a look at how we can correct that or fix that. So we're going to look straight down on our 3D view again. We're going to maximize our 2D view, and then we're going to close our 3D previews, flip to our front, and then we're going to press F on the keyboard. That way we'll actually zoom into the full width of our 2D view. Now we use this vector to define how far we want it to go out, or the part of our material that we wanted to actually machine out. This was the boundary of it, the maximum boundary. And we also use these two inside large circles. But really what we'd like to do is have the distance between our profile cut of our conrod and this vector right here to be the diameter or slightly bigger than the diameter of our tool. And right now it's smaller than that. Now there's a couple different ways we can do this, but I'm going to show you one way that is kind of interesting and unique and might become a very important tool for you in later jobs. So I'm going to delete that rectangle out of there, and then we're going to go to the other side and we're going to delete this rectangle and go back to the front again. Now in our smart snapping, we have an option that's not currently turned on, but if we turn it on, it will allow us to actually snap to the bounding box of a selected vector. So if I go up to Edit and go down to Snap Options, I can either press F4 or I can just click. And these are all of the snapping options that we have, and there are a ton of them, and that just shows how powerful our smart snapping and our geometry snapping options are. And the one I want to point out is right here under Smart Snapping Object Bounds. So if I turn that on, that'll allow me to snap to the object bounds. So let's click OK. Let's flip back over to our Drawing tab, and we're going to draw a rectangle. And as soon as I touch the edge of this conrod, the outside vector of the conrod, you'll see that a light blue line will pop up. And that indicates the bottom of my bounding box for this outside vector of my conrod. And also you'll see to the left and the right there are two black dots. Well, that is the corner where the left and the right intersect with the top and bottom. So if I go ahead and just move my cursor over to that corner, click my mouse button and drag all the way up to the other side, you'll see that now I can snap to the opposite corner of my bounding box and let go, and then select close, and now I have a rectangle that's the exact size as the outside line of my connection rod, which is perfect. So now what we're going to do is, with that selected, we're going to offset that outwards 6.2 millimeters. That's slightly larger than the diameter of our tool. I'm going to create sharp corners, and it doesn't matter if we select new or not. We're going to click offset. Close this down. We're going to delete this rectangle that we created, and then we're going to copy this to the other side because we're going to need it on the other side as well. Okay, let's flip back over to our Toolpaths tab now, and we can recalculate those two pocket toolpaths using this new vector. So let's just go ahead and select the outside vector, the new rectangle, and these two outside circles. And we'll double click on our pocket toolpath, and we'll just calculate that with all the same settings. Now let's just go ahead and reset our preview. Before we go ahead and preview this, we may as well go to the other side. So let's close this down. Let's go to the other side, go back to our 2D view again. We're on our back side now. Let's do the same for this pocket toolpath. We're going to select the outside rectangle and these two circles. We'll calculate that. And let's just go ahead and preview all sides with a fresh new preview. That way we can see exactly what we're going to get in the end. And everything should be cleaned up nicely. So that was the back. We flipped over to the front. And now we'll see that we've avoided that little mistake there. And on the other side, it's the same, and that looks great. Perfect. Now that we're happy with that, if we want to go ahead and save out these toolpaths, we can close this down and we'll flip back to our front and we'll save these toolpaths off. We can either output them as single toolpaths or we can group them together if we'd like. You'll need to choose an appropriate post-processor for your CNC or your controller and then save those off, and then go ahead to your backside and do the same with those. Save those all off, close that down, and you should be ready to run this on your CNC. Now let's save off this file. File, save as, and we'll save it as Conrad 2D Toolpaths. Click Save, and yes, we're going to replace the one that's there. That ends this demonstration. I really hope you found that helpful.